Okay, this is still section 1.2, and that's dealing with working with minutes, degrees, and seconds in our trigonometric work. So I've got 3 examples here in this tutorial that I'm going to do. The first one here says to convert to degrees, minutes, and seconds when you have a decimal place. So this is similar to what we've done earlier in the last tutorial where we went the other way, but not quite the same. So what you do in this case is you use multiplication here in our case. So what you do is you take the decimal portion. So you say it's 86 degrees, and you take 0.6735 degrees, and you multiply that by 60 to get how many minutes that would be. So let's do that on our calculator here. 0.6735 times 60. So I get 40.41. minutes. So now I know that I have 86 degrees, 40 minutes, and I'm not sure 0.41 minutes. Let's convert 0.41 minutes into seconds. So take your 0.41 minutes. Now you're dealing with minutes here, so you still multiply by 60 because there's 60 seconds every minute. So multiply by 60 again. And that will give you seconds. So take your calculator here, go 0.41 times 60. And you get 24.6. So let's say that seconds. So this equals 24.6 seconds. Or if you like, if we're going to round that off to the nearest second, that's 25 seconds. So therefore my answer can be 86 degrees, 40 minutes, and to the nearest second, 25 seconds. So you use the multiplication technique there instead of using, as we did in the other one, the division technique. Okay, the next example here deals with remembering what parallel lines do in terms of remembering what corresponding angles are and how corresponding angles are equal, remembering what alternate interior angles are and how they're equal, and those geometric relationships. So what we want to do is find the value of A and B. Well, we know that by geometric relationships between parallel lines with a transversal, that we are having corresponding angles between this angle here and this angle B here. So that we know B, because B corresponds with the given angle. We know that here we have an angle, angle B, that's going to have the exact same measure. It's going to be 59 degrees, 38 minutes, minutes, just one accent, and 27 seconds. Okay, so that means we have to calculate B. Now A. Angle A is a supplement to angle B. So that means we can minus the value of angle B from 180 degrees to get our value for it. Okay, so this is a little bit different than simply regular addition because you have to remember the 60 degree thing and the 60 minute thing. So let's say we have 180 degrees, and we have that's 0 minutes and 0 seconds, and we want to subtract 59 degrees, 38 minutes, and 27 seconds. So we got to do some borrowing here in a way that we have numbers to work with in the seconds category and minutes category. So if I borrow 1 degree, if I take 1 degree out of there, that converts this into 60 minutes. Okay, so we're good there. However, I need to borrow 1 minute to get 60 seconds here, so I can borrow 1 minute here now. So this would then turn to 59. I should have left a little more space. I'm going to put the 59 here. So I'm borrowing 1 minute there, and this becomes 60 seconds. So then therefore I have a 60 above that, I have a 59 above this, and I have a 179 above that, because I borrowed 1 degree to get a bunch of minutes, 60 minutes, and then I borrowed 1 minute to get 60 seconds, so I could do my subtraction. So I do my subtraction, I get 43 seconds here. I do my subtraction here, I get 21 minutes. And I do my subtraction here, and I have 120 degrees. So that would be the measure, 120 degrees, 21 minutes, 43 seconds. Just the only difference there is being careful to properly borrow when everything equals 60, right? 60 minutes gives you a degree, 60 seconds gives you a minute. Okay, one last example here in this section, and that's to find the smallest positive value of theta given in this case. So what we're doing here is we're looking at cosine as being a decimal number here, and it is, what we're trying to find is the angle in the fourth quadrant. So simply put, all we have to do there is we first have to draw a little bit of a picture here. So let me draw my Cartesian plane out here. Okay, so there is my Cartesian plane. So here I want to look at it and say, okay, well, fourth quadrant angle, I have to draw my value here. So my reference angle, I'm going to put reference because that's what we're dealing with here, is right there. Okay, and the value for this cosine value here, if you remember that cosine in the fourth quadrant should be a value that's, since cosine is actually x over r, and the x is going to be positive, it makes sense that it has to be positive. So what we do is we can convert that decimal number into a degree. Okay, so here we are, clear. We take, make sure it's still in degrees, 0.76352, and I want to convert that into, so I go second function cos, and that is going to be equal to 40.22449 degrees. Okay? Okay, so that is my angle in degree measure. Obviously, I would say that if I wanted the smallest positive, I want the smallest positive value. This is an actual value of, that's negative, right? That's the negative value of it. So that's our reference angle there. So we have to find this value here. Okay, so how do we get that? Well, it would simply be the same as taking this value here. One revolution is 360 degrees, and subtracting this here value from 360 degrees. So if I put this here and put a negative in front of it and just add 360, I will get the value of our angle. So therefore, theta is equal to 319 degrees, 0.77550 degrees, I think. Let's see, 1, 2, 3, 4, 5. I probably rounded off improperly there. I wasn't looking good. So that's degrees. Now,